Dear children, today we will learn reducing a given equation in linear form and then solving it. See the question given in exercise 3.6. I'm taking fifth part here. This question is not given in linear equation form. X and Y you are able to see in the denominator also. So this is not a linear equation. So first of all, we will reduce it in linear form and then we will solve. So we will come to know that such equation can also be solved using the concept of linear equations. So to reduce it in linear form, we will first separate the first term and the second term. So we can write xy as this is the denominator of the both. So we can write them separately. So if we write it separately, y and y will get cancelled and x will get cancelled, and this equation will become 7 upon y minus 2 upon x is equal to 5. This will be the first equation. Similarly, we will also change the second equation. So if I separate the two terms, then the first term will become 8x upon xy. X and x will get cancelled and 7y upon xy. So this time y and y will get cancelled is equal to 15. Therefore, the second equation will become 8 upon y plus 7 upon x is equal to 50. Then we will assume 7, we can write it like this, 7 into 1 upon y, and then minus 2 into 1 upon x is equal to 5. Similarly, second equation can be written as 8 into 1 upon y plus 7 into 1 upon x is equal to 15. Then we will assume let 1 upon y is equal to a and 1 upon x is equal to b. So if we put 1 upon y is equal to a, this equation will become 7a minus 2b is equal to 5, and then it is 8a minus 7b is equal to 15. Then children, these equations are now converted into linear equations in two variables. So now we will solve for a and b. So the coefficients of b are smaller in comparison to the coefficient of a. So I will equate the coefficient of b. I'll multiply this equation by 7 and I'll multiply this equation by 2. So this will become 49a minus 14b is equal to 35, whereas the second equation will become 16a minus 14b, this is plus 14b is equal to 30. Since the signs are already reversed, so we will add the two equations, and when we add, this b will get cancelled and we will have 65a is equal to 65. That gives a is equal to 65 upon 65. So this will be 1. The value of a that we are getting is a is equal to 1. Put this value of a in this equation, or simply if a is 1 upon y, that means if a is 1 upon y, a is 1 upon y, that means put the value of A here, this will give us that 1 is equal to 1 upon y, or we can say that we got y is equal to 1. Now children, putting this value of y in any of these two equations, we will get the value of x. So if I put this value of y here, I'll get 7y. Put it in first. Let us call this as first. Put y is equal to 1 in first. Children, I'll get 7 minus 2 upon x is equal to 5. Take this 5 this side and this 2x this side. So I'll get 2 is equal to 2 upon x. Or I can write it as cross multiply and get the answer. 2x is equal to 2. Therefore, x is equal to 2 upon 2. That is 1. So, x is also equal to 1. Therefore, the answer to this question is x is equal to 1 as well as y is also equal to 1. Or we can write that the answer is 1 and 1. So this is how we can solve using the concept of few equations which are not actually the linear equation but can be solved using the concept of linear equations. Before we start solving this question, let's concentrate upon the given equations first. In these equations, the denominator of the first term in the first equation and denominator of the first term in the second equation have something common. And similarly, the denominator of the second term in both the equations are again having something common. So let's assume this common term as a. So 1 upon 3x plus y is equal to a, and 1 upon 3x minus y is equal to b. Let's put this in the given equation. So we will have a plus b is equal to 3 by 4. Since we have denominator in this, to remove it, we have to multiply both the sides by 4, and therefore the equation will become 4a plus 4b is equal to 12. Similarly, let's put a in place of this 4. So this will become a upon 2. So this is a upon 2 minus, similarly in place of this, you will write b, and b upon 2 is equal to minus 1 upon 8, and then again remove the denominator. We have to multiply both the side by 8. It will become 4a minus 4b is equal to minus 1. There is a mistake. This 4 and this 4 will get cancelled. So we will have only 3 in place of 12. So this is 3 only. Now we are comfortable with the equation, so we will assume them as first and second equation, and we will eliminate the 2. When we eliminate, we will have 8a is equal to 2. Therefore, the value of a is 1 upon 4. This value of a, let's put here, where we assume a is equal to this. And let's find out the value of b also. So if I put a is equal to 4 in the first equation, I will be getting, in place of a, I am writing 1 upon 4. So this 4 and this 4 will be cancelled, and I am left with 1 only. 1 plus 4b is equal to 3. That means 4b is equal to 2, and therefore b is equal to 1 by 2. I got the value of a and b both. Let's put this value in this. So if I put a is equal to 1 by 4, this will become 1 upon 3x plus y is equal to 1 by 4. Cross multiply and you will get that 3x plus y is equal to 4, or take reciprocal both sides. Similarly, if I put the value of b here, I'll be getting 1 upon 3x minus y is equal to 1 by 2. Taking reciprocal both the side, I'll be getting 3x minus y is equal to 2. Now eliminating once again and only by adding, because the signs of y are already reversed. So this is 6x is equal to 6. Therefore, the value of x is 1. Now we will assume this equation as third and this one as fourth. And let's put the value of x is equal to 1. X is equal to 1 in third. So if you put x is equal to 1 in third equation, it will become 3 plus y is equal to 4. And therefore, you will get that y is also equal to 1. By transposing this 3 this side, y is also equal to 1. Therefore, the answer is 1 and 1. Children, you come to know that the equations given in this question are not linear equation in two variables. Even then, we are able to solve them by using the concept of linear equations. By reducing these equations in linear form first, and then we are able to solve them. Now let's solve the word problem. This is the first part of this question number second given in your NCERT. This is the first part of question number 2. First part, question number 2. Ritu, having mastery over word problem should be the main aim while solving the question of third chapter. So Ritu can row downstream 20 kilometer in 2 hours and upstream 4 kilometer in 2 hours. First of all, you need to understand what is downstream and what is upstream. Children, suppose you are sailing in water and water is moving in this direction and your boat is also sailing in the same direction. Then we will say that we are moving in downstream. Downstream is always very supportive. That will give you a push and will increase the speed of the boat. If suppose the speed of the boat is x kilometer per hour, whereas the speed of stream is y kilometer per hour, and if you are moving in downstream, that means it will support you. So the resultant speed of the boat in downstream, speed in downstream will become x plus y kilometer per hour. So we can down to earth. That means very humble, very polite, very supportive, you may say. Similarly, downstream, that means it is going to be very supportive, very polite, and will help you in sailing. Therefore, it will increase the speed of the boat, x plus y kilometer per hour. But if the water is flowing in this direction, but you are sailing in reverse direction, in that case, you have to put your efforts to sail. That means the water is not supportive. It is giving you a push in opposite direction, thereby decreasing your speed. Therefore, in this case, in upstream, the speed will become x minus y kilometer per hour. This understanding is must while you are solving the questions of downstream and upstream. Now, Ritu can row downstream 20 kilometer in 2 hours. So, speed in downstream is this, distance is given, and time is given. You must have learned a relation between speed, distance, and time. So, you must be knowing that speed is equal to distance upon time. So, children, the speed in downstream is x plus 5. The distance given to you is 20 kilometer and the time taken is 2 hours. So when you cancel, your equation will become x plus y is equal to 10. This will be the first equation. Similarly, put the value, the second slot of the values given to you. If she is sailing in upstream, the speed will be x minus y. She is sailing it, covering this distance, the same distance. Sorry, she is covering 4 kilometers. So distance is 4 kilometers in 2 hours. So that means the second equation is x minus y is equal to 2. Now you may eliminate to get the value of x and y. Now this is 2x is equal to 12 implies x is equal to 6 kilometer per hour. Putting the value of x in the second equation or in first equation, you will get that y is equal to 4 kilometer per hour. Since it is a word problem, you must give your answer in words only. So you will write that the speed of boat in still water is 6 kilometer per hour, whereas the speed of stream is 4 kilometer per hour. So, learning this concept that the speed of the boat in downstream is always supportive, x plus y, and in upstream, it is not supportive. Therefore, the speed will reduce and therefore the resultant speed is x minus y kilometer per hour is the key point to solve such questions. Let's do one more question. This question is related to work and time. The key point to solve work and time question is to get the one day work, to get 1 day work. First of all, what to suppose in this question? Children, whenever you are solving a word problem, 99.9% you have to assume whatever he wants you to calculate. So first of all, I'll read out the last line of the question. Find the time taken by one woman alone to finish the work and also the time taken by one man alone. Now read out the question. 2 women and 5 men can together finish an embroidery work in 4 days, while 3 women and 6 men can finish it in 3 days. Find the time taken by one woman alone to finish the work. So let's suppose let one woman finishes the work in X days. As I told you that the key point for such question is to get 1 day work of each and every one. If women and men both are employed, so you will get 1 day work of one woman. So in X days, the one woman complete the whole work. In 1 day work, in 1 day, she will not be able to complete the whole work. She will be able to do a part of it. So how much part of it she will do? 1 day work of one woman is equal to 1 upon X part of the work. Suppose I finish any work in 2 days. In 2 days, I am finishing the whole work. I am finishing the whole work in 2 days. Therefore, in 1 day, I will be doing half of it. So, these number of days will become 1 upon 2. I will have to take reciprocal of it. Similarly, this woman is finishing the whole work in X days. Therefore, her 1 day work will be 1 upon X part of the work. Similarly, male members are also employed here. So I will imagine that one man finishes the work in Y days. In Y days, he is able to finish the whole work in 1 day. The man will do 1 upon Y part of the work. I hope it is clear to everyone. I have explained it with an example also. Now, see what he did. He got the work done by employing 2 women and 5 men for 4 days. So let's get one woman work is 1 upon X. Therefore, 2 women work for 1 day is 2 women work for 1 day. 1 day work of one woman is 1 upon X. Therefore, 2 women's work will be 2 by X. And these 2 women are working for 4 days. So 2 women, 4 days work will be, this is multiplied by 4. This is 8 by X. Similarly, he employed 5 men. Therefore, 5 men 1 day work will be 1 man does 1 by Y part of the work. Therefore, 5 men will do 5 upon Y part of the work. And they are also working continuously for 4 days. So 5 men 4-day work will be 5 fours are 25. Both of them together, that means 2 women and 5 men together finishes the job. That means this part of the work and this part of the work when added will give you full one work. One embroidery work will be completed when I add the work done by 2 women and work done by 5 men in 4 days. So that means adding these two, I'll be getting 8 upon X plus 20 upon Y is equal to 1 complete work. So this will become the first equation. Now in the second condition, he says 3 women and 6 men can finish it in 3 days. So 3 women 1 day work is 3 by x, and they are employed for 3 days. 3 women, 3 days work will become 9 upon x part of the work. And how many male members are employed here? 6 men. 6 men are also working for 3 days. 6 men, 1 day work is 6 by x. 6 men, 3 days work will be 18. It should be by 18 upon y. Now children, women have finished 9 by x part of the work, whereas male member has finished 18 upon y part of the work. So if you combine the two, they are able to finish the job in 3 days. So in 3 days, both of them together again have finished one complete work. So there are two ways of getting one work complete. Either you hire 2 women, 5 men for 4 days, or you hire 3 women and 6 men for 3 days. So in both the condition, one complete work will be finished. So this is the second equation. Now you have seen these two equations. They are not exactly the linear equation in two variables. We have to reduce them in linear equation first. That means the first equation is 8 upon x plus 20 upon y is equal to 1. Whereas the second equation is 9 upon x plus 18 upon y is equal to 1. I hope now you are expert in solving such equation. You will assume that 1 upon x is equal to a and 1 upon y is equal to b. So in place of 1 upon x, 8 into 1 upon x plus 20 into 1 upon y is equal to 1. So, and in the second, 9 upon into 1 upon x plus 18 into 1 upon y is again equal to 1. So in place of 1 upon x and 1 upon y, we'll put a and b. So the equation will become 8a plus 20b is equal to 1, whereas it is 9a plus 18b is equal to 1. Children, we know, we are able to see here the coefficient of A are smaller than coefficient of B. So better it is to multiply by 9 and multiply this equation by 8 to get the coefficient of A same. So when you multiply the whole equation, this will become, we will write these two again. So this is 9 8 72A plus 180b is equal to 9. Similarly, 72a plus 144b is equal to 8. Now to eliminate, we have to change the sign. Let's change the sign and get the value of a and b. So this is cancelled, and now we have 36b is equal to 1, b is equal to 1 upon 36. Now, if you want, you may get the value of a by putting the value of b here in this equation, or directly you may put the value of b, 1 by y is b. So, Directly also you can get, without getting the value of a also you are able to get the value of x and y. So how will we proceed? We will proceed from here, children. We have 1 upon y is equal to b. So in place of b, I'll be putting its value. 1 upon y is equal to 1 upon 36. Taking reciprocal both the sides, same thing you can do both the sides of the equation, the things will remain equal. So that means y is equal to 36. Put this value of y in this first equation. Let's call this one as first. So put y is equal to 36 in first. So you will be getting 9 upon x plus 18 upon 36. Why I am assuming this one as first and putting the value here, it is clearly visible that 18 will cancel 36 and our calculation will become easy. So always keep an eye on how we are able to get the result in a very simple manner. So 1 minus, take this 1 by 2 that side. So that means 9 upon x is equal to 1 upon 2. Cross multiply and you will get that x is equal to 18. Children, we have assumed that x is the number of days the women are taking. Therefore, one woman will finish the job in 18 days, whereas one man will finish it in 36 days. Always highlight the answer, keeping them in box. So one man will finish it in. That's all for today.